In previous videos, we used the sine function to simulate motion. In this module, we're going to use the sine function to create sound. I'm going to begin by taking a table and using it to create one complete cycle of a sine wave by just going through degrees from 0 to 359 and then adding the sine of each degree to the table. And so now I have a table that has 360 items. The sine of 0 is 0, and sine of 1 degree is 0.017, and so on. Now, I can take this table and graph it. So I'm going to say from items from 1 to 360, let's just make a graph of that item, and you'll see that we trace a sine wave. So let me go back to set the turtle back to the beginning. And now let's do the same thing again with the pen down. And we're going to see that if we just graph each item in the table, as we'd expect, it generates the curve of a sine wave. Now that we've established that we've got a table with one cycle of a sine wave, here, from degrees 0 through 360, let's create another table, and we're going to create this table by first setting it to 0, so it just has an empty table. And now let's go through and add each of the cycles in the first table to the second table and do that 100 times. And so if we multiply 360 items in the first table times 100, we get 36,000 items that just repeat the cycle of the sine wave over and over and over again. So once we've done that, we can actually play these cycles and send them to the computer speaker. And we're going to send them at a rate of 36,000 samples per second. And if we do that, that will generate a 100 hertz tone, because if one cycle is 360 items, then 100 cycles in 1 second means each cycle is 1/100th of a second. So I can multiply that and send them twice as fast, and if I do, I get a 200 hertz tone. Or if I multiply by 3, I get a 300 hertz tone or a 400 hertz tone. So I'm just playing them back faster and faster, and as I play the cycles back, I get a higher and higher pitch sound. So now the sine function is not just a theoretical construct, it's the method by which we're going to generate sound with a computer. Now, we can also generate aperiodic sounds. So what I'm going to do is I'm going to create another table, and I'm going to make it empty. And now what I'm going to do is I'm going to fill this with random numbers. And so now I just have a series of random numbers ranging from 001 to 9.999. And if I have these random numbers that I put in the table and I play that sound back, what I get is noise, because there's no pattern. If I would graph that, I would find that it was no perceptible patterns whatsoever. So now I'm going to graph the items in the noise table. And as the turtle moves back and forth, we can see there's no pattern. It's just random. So as I move the speaker back and forth randomly, I get noise. So if I play it back with a discernible pattern, like a sine wave, I get a tone or periodic sound. And if I play random sounds back, I get aperiodic sounds, which turns out to be noise. So this is how you use a computer to generate sound. You can play a pure tone, and since once you can play a pure tone, you can recreate any periodic sound. We can create speech and music in this way. That's what we're going to explore in the next module.